We're here for section 8.2, Pythagorean theorem and its converse, an easy one. And for many of you, it's going to be a review because you did cover it a little bit in algebra. But if not, here we go. So we've got a right triangle, and we want to know how to be able to find a side of that triangle if we know two other sides. So this was discovered by Pythagoras. I think it was 1900, around there. And he discovered by just laying out rope that he could find or figure out what the third side was if he knew two sides. Now, it could be either a leg or the hypotenuse. So in a right triangle, you have two legs and a hypotenuse. The hypotenuse is the longest side. It's opposite the right angle. Right, biggest side opposite biggest angle, because these two angles have to be acute. As far as which is bigger between A and B, that doesn't matter. They could even be the same size. But we're going to call our legs A and B and the hypotenuse C. So we always isolate the hypotenuse in the theorem. This is the Pythagorean theorem. A squared plus B squared equals C squared. So the hypotenuse is always isolated. So, and again, A and B are the legs. Doesn't matter which is bigger. But the sum of the squares of the two legs add together equals hypotenuse squared. So that's how we work it out. So let's go right to it. So we're trying to find the hypotenuse in this case. So we always isolate that. Leg squared plus leg squared equals hypotenuse squared. Then we just do the algebra involved now to solve. So we square 3, we square 4, we add them together. And then to go from C squared to C, we take the square root of both sides. We're never going to include a negative answer here. We're solving for a side of a triangle, which has to be positive. So 3, 4, 5. All right, next one. So this one we have a known hypotenuse. What's missing is a leg. So leg squared plus leg squared equals hypotenuse squared. And again, we do the algebra. Let's square the numbers we know, which are 12 and 13. So 144, 169. We want to isolate that variable term, subtract 144 from both sides. And once again, we want to go from the variable squared to find the value of that variable to the first power. And coincidentally, we got 5 again. All right, now those two triangles happen to be what's called Pythagorean triples. That means that all three sides are whole numbers, which definitely does not have to be the case every time, but quite a few of them do come out that way. Now, if you learn the triples, that's nice. It'll save you some time. So every time you get that certain combination, because certain ones will come up quite a bit over and over again, and then that'll save you the time of having to set up the Pythagorean theorem and do that every time. It's not essential, but it'll just save you time. All right, so I put a few of them here. These are the more common ones. These are the smallest ones that are not all part of the same, what's called family, same ratio. So 3, 4, 5, 5, 12, 13, 8, 15, 17. If you knew at least those three, it'd be nice, but again, not absolutely necessary. All right, so we can add to this. If we just multiply each of those numbers by the same number, those will be family members of those families. So besides 3, 4, 5, then we can put 6, 8, 10, 9, 12, 15, 12, 16, 20, I'll do one more, and then 15, 20, 25. So notice those all are in a 3, 4, 5 ratio, and that could go on infinitely, but I'll just do that many. And we can do that with the other ones too. 5, 12, 13, let's just double each of those. Do one more. We'll triple each of the original ones. So those are family members, and the base member is the first one listed, but they're part of the same family, meaning that they're in that ratio. So that, again, will save you time if you happen to know those. All right, let me just add a couple others that are different. See, 9, 40, 41, and 20, 21, 29. There's others too, but the real big numbers usually don't come up very often at all. And like I said, if you don't, not essential, if you don't know the triples, all you do is just work it out and you do Pythagorean theorem, solve it that way. All right, one more problem. Here's one where we're not going to get a whole number. So this one's not going to be a triple. So we're going to do 6 squared plus x squared equals the hypotenuse. That's 12 squared. 36. 144. Subtract 36 from both sides. Square root. Now, as far as how you express your answer, yeah, there's a chance you'll have to break down the radical, so hopefully you know how to do that by finding the biggest square number factor, or you may want decimal approximation, so it just depends on what it says in the directions, and if it doesn't say, it's your choice. Let's go ahead and break this one down. All right, 36 goes into 108 3 times. So 6 rad 3. Now that combination is actually going to lead us to what's in the next section. That's a certain type of triangle. And we will get to that in the next section. All right, that's section 8 too.